The NESI board has 4 resistive sensors which can detect resistance, available at JP3, JP4, JP6, and JP5 respectively. For this video we're going to be using Q2, which is located at JP4 right next to the button in the upper left hand corner. We will begin programming these sensors by opening a new blank project in MPLAB-X. And in this outline of the code, we'll go ahead and start by including the string library because we will be using that to print that to the USB. I should mention that we're also going to be using a little bit of the functions from the USB library. So if you're not familiar with how to communicate with the computer via USB, it would be strongly recommended to go check out the USB video. So we begin by including string.h. And then in our void, we will just go ahead and initialize the USB. We're going to do USB.init. And if you are not familiar with the USB code, we're going to attach it to the computer so that way the computer knows that the USB device is there and that it's communicating with the computer through the USB. So we'll do USB.connect. And before that, I'm just going to put a delay to make sure all of the terminals on the USB connector are firmly in place before it tries to initialize that connection. So I'll do delay ms for like 100 milliseconds. And then after that's complete, I'll just turn the blue LEDs on to indicate that it was successful. Alright, so in our while loop here, what we're going to do is we're going to send the computer the value of the resistive sensor, or how much resistance it's picking up. It's not measured in ohms, it's measured in an arbitrary digital reading from 0 to 100 or 1024. So we'll begin by just turning on the blue LEDs, so that way each time this cycles we know that it's sending it to it. So turn the blue LEDs on. And then at the end of this code, we're just going to turn the blue LEDs back off. And then in here, what we're going to do is we're going to create a string or a character array. We're going to use a character array in this case, and we'll call it something like write. So, and that will be 32 bits long, or 32 bytes long. And then what we're going to do is we're going to create a value, and it's going to be an unsigned short that contains the arbitrary number for the reading of the resistive sensor. And then we will turn that unsigned short into we will take that unsigned short and we will put it into the right character array up here, so that way we can successfully print it to the USB serial port. So we'll just we're gonna store that short in the write array. And then after that, we will just print that write array to the USB port. So we'll print USB. We will print the write character array to the USB port. Alright, and then at the very end here, because this code will execute so fast that you won't really know it's going, what we're going to do is we're going to delay it for like a half a second. So delay for a half a second. Alright, so for turning the blue LEDs on, we can go ahead and use a function called LEDB, and then we're going to use the duty cycle function, and we will put just 1, because it's an indicator, it's not really illuminating anything. And then we'll turn them back off down here, so LEDB. And then for delaying for half a second, we know that function as well. It's __ delay _ms, and then for half a second it's 500 milliseconds. Alright, so for creating a character array called write, and it's going to be 32 bytes long, we'll say char for a character, and write, and we'll put 32 bits in there, in square brackets, by the way. And we'll set that equal, we'll just initialize it to nothing. It's not going to contain anything. They're all of the elements of that array will just be zeros. And then we're going to create an unsigned short that contains the sensor reading. So we will just do unsigned short. We'll call it RSI value, because that'll store the value of the resistive sensor. And then, because we need to store the actual value of the resistive sensor in it, we're going to have to use, or we can just initialize it to that resistive sensor function. So the resistive sensor function to get its reading is resistive sensors and and we're going to be using Q2 because Q2 is the sensor we're reading. It's available at JP4, and that's the one we're using. So get 2, and you'll see that this get argument, or this get function, it takes a couple of parameters here. It takes 2 integers, which is the samples to take and the interval to wait between those samples. So when you call this get Q2 function, it's going to take the reading from the sensor, and it's going to wait a certain amount of milliseconds, and it's going to take another reading, and it's going to do that as many readings as you tell it to do, and then it will average those readings and return it in the unsigned short. So for now, we're just going to do like 5 readings with 5 milliseconds in between. Seems like a fairly good average to go by. And that will take that, and it'll take the average of those 5 readings, and it'll store that in the unsigned short RSI value. And then in order to turn that short into a writable character from the USB port, it needs to be a string or a character array, and we can use the C library's sprintf function. So sprintf, and that takes a couple of arguments. It takes the first argument, which is the string for it to be stored in. And then the second argument here is what to write in the string. And then last but not least are optional parameters, and we're going to be using one. Alright, so for the string to store in, we've already declared our write array, and it doesn't have anything in it, so we'll just we'll store this to the write array, W. And then what we're going to store in the string is this RSI value here. So we're going to put in, we can't put in RSI value because that's not an actual string literal in C, but what we can put is a place marker, which allows us to then reference that place marker and that value in the optional parameters. So we would put here as %I for an integer, because an unsigned short is kind of like an integer if you're going to really get into the data types of C. And then we'll also put a new line character in here, so \n. So we're going to say %I, which is going to be the RSI value, and then \n, which is a new line. And then for the optional parameters, which references this %I, we'll put RSI value. And that will replace %I with whatever is in this RSI value right here. And then it will store it to the write character array. So now we have the value of the Q2 sensor stored in the write array. And then we can go ahead and use the USB.print function just to print that out on screen. So USB, and it takes a string, and we declared it, it's write. And now if we build this code and store it, and upload it to our NESI board, it should actually work, and you should be able to see it actually detect the various readings if you were to get the sensor, or if you were to apply some water or something to the sensor, you would see that reading go down, and I'll demonstrate that in a minute. And I forgot a semicolon at the end of this sprintf function right here. That should work better. So you'll see that if I open my serial port monitor, and when I plug the NESI board in, and then begin monitoring, I can see it returns a value that's very close to 1024, and that's because nothing's actually touching the sensor, and there's an infinite resistance in between those two leads on the resistive sensor. So if I were to dip my finger in some water and then cover that sensor on Q2, it's on the top left right next to the button, then you will see that value actually goes down, just like so, and it goes down to about 900 or about 1,000. And then as the water kind of dries, it'll go up, and when I remove my finger from the sensor, it'll actually go all the way back up to 10223. If you added even more or even less resistance, if you just shorted them together, you should be able to get at least to 0. You'll see that when I actually short the leads together, it gives me a 0 reading. That's because there's practically no resistance. There's just the resistance of the actual wire there. So that's how the resistive sensor works. You can get those readings using the get Q2 function, or get Q, whichever one you're using. In addition, you could use the resistive sensors and then dot read, and that'll just result the current value at that particular time. It won't do this averaging. It won't take like 5 samples and then average them together. It'll just take whatever reading it has at the sensor at any given time, and then it'll return that unsigned short.